In this video series, we're discussing the general linear model, and we've been in the process of working through the various designs we've encountered in the videos in this course and looking at the model associated with each of these designs. We've now come to the final design that we have covered, and that is the randomized design with covariate. So let's look at that and the accompanying model. Subjects are randomized to J experimental conditions and measured on both a response measure and a covariate. Each score is the sum of the mean, the condition effect, the covariate effect, and the residual that is unaccounted for by experimental factors. Now, as always, we could eliminate the term randomized and substitute it with observational. And in fact, the example I'm going to show you is an observational design with a covariate. But if you have not yet watched the videos on analysis of covariance with this kind of design, make sure you do so, because if you're not going to randomize, that's actually the best place to use a covariate. But if you're not going to randomize, there are a lot of cautions you have to take to avoid the dangers associated with making wrong causal inferences based upon observational designs in which you have a covariate that requires you to do some extrapolation. So be very careful with this kind of design. I'm going to leave the word randomized in here because that's the safest time to use this design. But again, as in the example we're going to look at, it's actually observational. And I'm not going to go through all the points about the covariate that I've already gone through in a previous video. So if you need to, watch that video. So let's look at this model now. We have a score for the ith person in the jth condition. Now that condition is a between subjects condition. We have mu, the mean of all the scores, plus the effect of being in condition J. That is what's primarily of interest to us, is what is the effect of being in condition J? Does it take me below the mean? Does it take me above the mean? And we have as many alphas as we have levels of that between subjects factor. Then we have a slope, and this is where the covariate comes in, because the covariate is related to our response measure. That's why we're using it. So we have a slope, and notice we only have one single beta. There's no subscript on the beta itself. Why? Because we're using a common slope no matter how many different conditions we have. So if we have two conditions, we have a common slope with the covariate and the response variable for each of the two conditions, the same if we have 3, 4, or however many. The x sub ij is the covariate for person I in condition J, and we're just going to multiply the slope by that person's deviation from their covariate mean within that condition. So everything you see here in parentheses is really not a big mystery. You don't need to worry too much about it. Just know that you're taking a slope for the covariate. But what we're really doing is taking a slope for the covariate's deviation from its within group covariate mean. So the little x sub ij is the actual score of the person, and the x bar sub j is the mean for the condition that that person is in. And then we have the residual of person I in level J. So what's really of interest here is the alpha. But just like in regression, if you slope a line and take deviations from the regression line, you have smaller deviations, that is a smaller residual. So by including the covariate in there and having the slopes of the covariate related to the response variable, we're then going to have a smaller residual than if we did not have the covariate in there. So looking at the example that we went over, this is relating income to race, and we thought that maybe education is also related to income, so we included that. So down here, the main figure of interest is this one here, in which we're looking at the differences between the various races in terms of income. And the sloped lines you see here are relating years of education to income. And note, as I pointed out, we only have one beta in our model because we are assuming there's no interaction of education with race. And so therefore we have the same slope for all the covariate relationships of years of education with income. So there is those differences between those lines are what's of primary interest to us. The difference between the green, the red, and the black line, that would be the differences in income after accounting for years of education. And as always, we have to go back and look at sphericity, which here turns out to be homoscedasticity in the same way we looked at it when we did regression, just like with simple linear regression. And in this plot here, I see I do not have homoscedasticity. I've got a really bad funnel effect where the variation is increasing as I get higher and higher income levels. So that is our final design and the corresponding model. I have one more video, however, where I'm going to talk about extensions to the type of designs that we have covered in this course so far.